Hi. Hello. And how are you? My name is Łukasz Wójciak, and I will be extending the previous topic because I have over a year of experience in creating a presentation engine for the iPad platform. And I will show you all the issues that we had to engage to provide a sensible app to our client. This is my Twitter account, my web page, and GitHub. All my code on GitHub is highly experimental, and you can use it, but it will fail, mostly. So, okay. When developing for the iPad, you have to realize that there are two rendering contexts in which HTML, CSS, and JS code run. One is mobile Safari. It's just the browser that you start. And the second one is called webUIView. And when you pack an app, for example, in PhoneGap and write in JS, HTML, and CSS, you will use webUIView. And these two rendering modes are not equal. The point is that mobile Safari uses the Nitro JS engine. So Nitro has just-in-time compiling, and the webUIView doesn't have it. The other thing is that webUIViews have very limited resources. Like the previous presenter said, that a lot of slides can crash Safari. So webUIView is even more strict about the resources. And you can't have many webUIViews in your app because they all share the same GPU and memory resource. In iOS 7, Apple mitigates that problem a bit. They added webUIView pagination. So you can have the C++ code automatically split the webUIView into pages and navigate through them using the native acceleration of the iPad. So then when creating slideshows, you don't have to worry about the memory management. Okay, so CSS GPU Acceleration, it's there, it's hidden, so you have to use special CSS properties like translate 3D or WebKit backface visibility hidden. WebKit perspective also works. iPad doesn't officially support WebGL, but there is a view called Add WebView. It's used to display ads in native apps. And there is a demo on someone's GitHub. When you Google it, you will find it. That hooks the add webUIView to webUIView, and you can actually create WebGL applications on the iPad. But it's only for little things because the code is highly unstable, the implementation is highly unstable, and more complex things are really slow. And you can use that only for internal use. So, for example, when distributing an internal app, because it won't go to the App Store, Apple won't let you do that. So, okay. The iPad has Retina image, iPad 3 and iPad 4. They look very good. We can agree with that. And they are big, and we have many memory restrictions on them. So we can have approximately 7 megabytes of images in memory at once. In the webUIView and in mobile Safari, memory isn't released when removing images from the DOM. So we can use, for example, jQuery remove to remove the image, and the memory will not be freed. It will be freed in the next garbage collection cycle, which is often too late, and our app will crash when we have a lot of images. You can free the memory by explicitly replacing the image. If you replace the image with something like data image div base 64, sorry about that. It's 1 pixel on 1 pixel transparent div image. Then you will force the memory cleanup. Large images need GPU memory. So the memory of the browser is one thing, and the memory of the GPU is another thing. Max texture size for one page of memory is 4096 by 4096, and it's used for rendering in native apps. WebUIViews have half of it, so you can still use a very large image without swapping the memory pages. When you swap, you have lower performance, so don't go overboard with the images. The maximum image size is 5 megapixels for PNG, TIFF, and GIF images, and this is true for devices with at least half of the RAM. So iPad 1 has this limit even lower. And what is interesting, it's only 2 megapixels for JPEG images to display larger images on the web and in the native apps. The iPad uses something called subsampling, so it can hold 32 megapixel images, but it first converts them to 2 megapixels images by the CPU, and the lower subsampled image is then passed to the GPU. So it is very slow, and yeah, you shouldn't use that much images in web apps. Another thing is that JS execution time is limited. What does that mean? It means that if you have a loop that will go over 10 seconds, your app will crash. You will crash Safari, or you will crash your phone app. So 10 seconds is the limit. It's not so bad because you don't do big data processing on the iPad, but this time is true for the mobile Safari, for Nitro. It gets worse without GAT. So in the WebUIView, you have 10 seconds, but it's much, much slower. So if something takes 10 seconds in the browser, you are sure that it will crash the WebUIView. So you need to aim for 3 seconds or less one thread execution time. Web workers. Don't use web workers on iOS 6. They are slow as hell, 5 times slower than the native thread. We tried that. It failed. iOS 7 has, let's call it for Apple, power workers. They are actually 10 to 20% faster than the native thread, but they still let you do some more processing. Okay. The next thing that is weird on the iPad is that JavaScript execution is paused on many events. So when you switch apps, your JS is being paused. When you're doing a big calculations and you switch up, then the calculation will fail. If you do an AJAX request and you switch up, the calculation will fail. The AJAX request will fail. When you load the screen and when you use native scroll. So when you scroll the web page using the nice deceleration effect, then the JS execution is paused. Okay, so we have CSS GPU Acceleration. It can work smooth, but the acceleration creates new rendering layers, which the GPU has to handle. Never try to animate the width and height. It will be always slow and will probably crash the app. And yeah, 3D rendering layers eat up GPU memory. Hardware acceleration composition, you need to keep the DOM flat because it will cost you. If you have a div that is hardware accelerated and inside have a div that is not, and inside have a div that is again hardware accelerated, you will get very poor performance on that. Image rendering yikes. So image render isn't equal or even close to image load. The iPad first loads the image into the storage memory and then processes it to the GPU for render, which can have the effect that the website has loaded, and then after a second the images pop in. It's better for iOS also to not guess the image size. So if you have images and if you can calculate the size, put their size into the inline CSS styles, because it's less expensive on the CPU if it knows the image size. Synchronize image render. So if you don't want the pop-in effect because it doesn't look good, create a page loader and use request animation frame to re-render that view. Then the iPad will collect all the rendering assets that it needs, and if you put a nice fade-in effect, for example, in there, you will have a smooth page transition. Native scroll is cool, yeah? So, except that it blocks the UI thread, it doesn't eat up webUIView memory. If you use some scrolling library, you will have performance issues and memory issues. There are JS events for scrolling, so if you scroll, actually there are on-scroll and on-scroll progress events, I think. And it will be easily enabled for elements by using the property WebKit overflow scrolling touch in CSS. And they are a little bit annoying. So JS events for scrolling, they are fired, but they aren't fired regularly. So you need to create a class or a handler to work them out. It took us about a week, and it still didn't work perfectly. When you do the scrolling, the webUIView and Safari JS execution is paused, so all the great GIF animations will pause also. And the most annoying thing is that there is no DOM position updates. If you have a list of buttons or just a list, and you scroll quickly and try to press the button, you won't press the button under your finger. You will press the one that was there when you started the scroll. Yeah. Our QA team cheated us with that for about 2 months. So. Scroll events don't bubble. So when you write your handler to handle all those nasty scroll issues, and you want to create a delegate and just listen for new objects and handle them, you can't. You have to bind the event to the handler each time a scroll element appears on the screen. So that was for the rendering part. Now for the storage part. So we can use local storage. It has 5 megabytes on the iPad, both in mobile Safari and webUIView, or you can use the deprecated WebSQL. WebSQL can have up to 15 megabytes of storage, but it will prompt the user after you use more than 5 megabytes. The user can reject that, and you have to handle this. iOS 7 actually has a WebSQL bug. If the database is initially larger than 5 megabytes, it won't let you create it. You have to create a smaller database, then extend it to 5 megabytes to ask the user's permission, and then you can extend it further. Storage persistence. There is no such thing as web storage persistence on the iPad. All the files, even when you use phone apps, are stored in a folder called cache, and that folder gets cleaned up when the iPad decides it needs to clean up. So we had bugs that were called content dumps, when the client was using the app and suddenly all the content was gone, and we didn't know why. But we found that behavior, and luckily someone created a PhoneGap plugin that uses the native SQLite database available in the iPad SDK. The API is 100% compatible with WebSQL. You can address up to 2 gigabytes of memory on the database, which is more than 50 megabytes. And you simply, after installing the plugin, you just use Windows SQLite plugin instead of Windows Window Open Database. And it works, and it's great. Hover states. So the iPad has nasty hover effects, and they are slow, they are clunky. When you have a hover effect on some DOM item, it just doesn't look good. So if you want to mimic the mouse hover effect, you will have to disable the tab highlight color, so you don't have the gray border around. Add to every CSS class the active pseudo selector, and then create document at event listener touch start function. It can be anything. The important part is that you use capture mode. When you use capture mode, then iPad will process this and will magically disable the weird hover behavior and just fall back to normal behavior. So what's new in iOS 7 that it's not implemented in iOS 6? So we have seamless iframe. We can create an iframe that inherits the styles of the parent document. I see some use cases for it, but the iframe still has sandbox.js and content, so we can't easily communicate with the parent page. It has the page visibility API, so we can tell when the user actually is on our page. Prior to that, we had to check with the timer that some DOM element can move or it can't move, and then fire appropriate events. So what's more, video subtitle support, yay. Many CSS properties like city position, flexboards, regions, clip path, that is very awesome. The less input type date time was removed. So if you have an app or a website a form that relies on that field, you better check it, because it will be re-rendered as a normal input field. The new toolbar causes problems. The transparent toolbar that when you scroll down your page, it creates a blur effect and stuff like that. It has issues with header positions, and often the page and PhoneGraph app can pop under the toolbar. Additionally, the default behavior of the little bar with the time and the network coverage is different than in iOS 6. In iOS 6, when you didn't provide the properties in the HTML meta tag, it was white letters on black screen, on black background, which was quite good. In iOS 7, the default is black text on black background, so you get nothing there. And what is funny, if you use a routing based on, if you create a single page app and that app is being added to the home screen, it won't work because the home screen doesn't support browser history at all. So your app is dead then. And the absurd, the text on the top, WebKit current playback target is wireless change, is actually a name of an event. You can hook up to it, and it will tell you when the iPad uses AirPlay mode to display something on Apple TV or some other device. Yeah, they went a little over the board with this one. Okay, so the second absurd thing is that when you're in portrait mode and you tap on an input field and the table pops up, then the screen proportion changes, the visible proportion changes, and an orientation landscape media query takes effect. So if you use media queries to render your page, then the layout will change after tapping on input fields. And another strange thing is that there are no alert, confirm, and prompt bots support in home screen apps. So if you want to prompt your user for something, you have to just create a JS component for it. Okay, so what we learned is that another day is another 200 milliseconds of performance improvements. There are many more issues, and It's a long fight to have a near native app performance. It can be done, but it's not easy. And if you we created actually a bit presentation engine for a big company, which used many components on this page. The components could trigger other actions. And it was a horror at first, but then we managed to satisfy the client. Okay, question time. Anyone? Come on, come on. Don't be afraid. I know you are scared, yeah? Okay, are you sure? Okay, so I guess no questions then. Okay, thank you.
Thanks.